Yes, dear students, now we are going to start question number 10, part first. I equal to under root x upon under root a cube minus x cube dx. It can be written as under root x upon under root a cube minus x power 3 by 2 whole square. It will be the same as x cube when 2 cancelled by 2. Why we have done this? If we take this t, then under root dx equal to dt. That is why we have taken like this. Now let x power 3 by 2 equal to t. And 3 by 2 power of x 1 by 2 dx equal to dt. We can write it as under root x dx because power of 1 by 2 power of x 1 by 2 can be written under root x dx equal to 2 upon 3 dt because it will be changed. Numerator will be denominator and denominator will be numerator. Now put these values here. I equal to under root x dx equal to 2 upon 3 dt upon a cube. A cube a square a cube minus t square it can be written as 2 upon 3 dt upon power of a 3 by 2 whole square minus t square. Now, dear students, it is in standard form, you see. Then we can apply the formula. Which formula we have to apply? The formula sine inverse x upon a. Then apply the formula and find out the solution. Equal to 2 upon 3 sine inverse t upon power of a 3 by 2 plus c. Now putting the value of t, we find that 2 upon 3 sine inverse power of x 3 by 2 upon power of a 3 by 2 plus c. Again I explain you with a I equal to integration of under root x under root a cube minus x cube dx. We want to convert it into standard formula. How can we change it so that it can be changed into standard formula? Let x power of x 3 by 2 equal to t and power of x 3 can can be written as power of x 3 by 2 whole square. Because 2 cancelled by 2, then it will become only x cube. Then let power of x 3 by 2 equal to t. Then dy by dx of power of x 3 by 2 equal to 3 by 2. Power of x 1 by 2 dx equal to dt. And we can write power of x 1 by 2 equal to under root x dx. And 3 by 2 when transferred in from left to right, then it will change. It will be changed and it will become 2 upon 3. Now I equal to 2 upon 3 dt. 2 upon 3 dt under root x dx. Instead of under root x dx, we can put 2 upon 3 dt, and a cube can be written as a power of a 3 by 2 whole square. Now it has been changed into standard form. What is the formula of this standard form? This is in the form of 1 upon integration of 1 upon under root a square minus x square dx. This is equal to sine inverse x upon a plus c. Then we have applied the formula sine inverse x upon a, where instead of x we have to write t, and instead of a we have to write power of a 3 by 2 plus c. Now we can put the value, we put the value of t and we find the solution which is here. Now we are going to start second part of question number 10. Second part of question number 10. Question number 10, part second. I equal to 1 upon under root a square plus x square, power of it 3 by 2 dx. Now we can put instead of x a tan theta, so that it will become 1 plus tan square theta equal to sec square theta. And I have explained you about that. Let x equal to a tan theta, dx equal to a sec square theta d theta. dy by dx of tan theta equal to sec square theta d theta. And x upon a implied a tan inverse x upon a equal to theta. Therefore, I equal to, instead of dx we can write a sec square theta d theta upon under root a square 1 a square tan square theta, value of x d theta already we have written. Now next it is equal to a sec square theta d theta upon b, take common a square and outside under root it will become a, and here 1 plus tan square theta, and this will become sec square theta. Then the further step, a sec square theta d theta upon a sec theta, because 1 plus tan square theta equal to sec square theta, it is in under root. That is why if under root will be removed, then square will also be removed. Now a cancelled by a, square cancelled by sec theta, it is only sec theta d theta. And you know very well the integration of sec theta. Integration of sec theta equal to log sec theta plus tan theta plus c. Now you know very well that tan theta equal to x upon a, because here if we take tan theta, then x will be transferred to left hand side upon in denominator, and it will become x upon a. Then tan theta equal to x upon a, and sec square theta also can be written in the form of tan theta. How can we write it? Log under root 1 plus tan square theta. Sec theta can be written as 1 plus tan square theta, and it is already tan theta. Then now we have to put only the value of tan theta. Next, log under root 1 plus x square upon a square. The value of tan theta, if there is square, then we have to put the square also. And tan theta equal to x upon a plus c equal to log a square. We can take LCM, then it will become a square plus x square plus x upon a plus c. Now a can be taken again LCM, then it will become log under root a square plus x square plus x upon a, and this is equal to form m upon n. Then we can write by logarithm rules log m minus n means log under root a square plus x square plus x minus log a plus c. You know log a and c both are constant values. That is why instead of both of them we can write c dash. Then it will become log under root a square plus x square plus x plus c dash, and you can write also c, because there is no any difference between c and c, that both are the constant values with a no difference. Then you can write it like this. This is your solution, and now the turn of next question. Here there is no necessity to explain more, because already I have explained you very well these type questions solutions. That is why you can understand. Now we take the next question. Next question, 11 part number first. Question number 11 part number first. Integration I equal to 1 upon 1 minus x square and power of this equal to 3 by 2 dx. Now we have to suppose or imagine. So imagine that x equal to sine theta. Why we have taken sine theta? We haven't taken any other trigonometrical ratio, because if we take any trigonometrical ratio, then it will not be converted into standard form. That is why if we try to do taking anything else sine theta, then it will not be solved, and we have to again come back and take x equal to sine theta. And if we take x equal to sine theta, then it will become 1 minus sine square theta, that will be cos square theta. Now let x equal to tan theta, sine theta. Sorry, because I have explained you that we take sine theta, but by mistake I have written tan theta, which is wrong. Now dx equal to cos theta d theta. Then we make dy by dx of it in respect with theta. Then I equal to cos theta d theta upon 1 minus sine square theta and power of it 3 by 2. Now you can put here cos square theta. You know very well by the formula of trigonometry that it will become cos square theta, and cos theta d theta upon cos square theta and power of it 3 by 2, and square cancelled by square. 1 cos theta cancelled by 1 cos square theta, then it will become 1 upon cos square theta d theta. And you know very well that 1 upon cos square theta will be changed into sec square theta. Then we can write it sec square theta d theta, and you know that this is the standard formula, and we can write instead of integration of sec square theta d theta equal to tan theta plus c. Now we have to put the value of tan theta. I explained you before many days in the beginning of chapter number 2 that if this is theta, then this is perpendicular because it is opposite side of theta, and it will be x, and we can put here 1, then this hypotenuse will be 1, because 90 degree, opposite side of 90 degree must be hypotenuse in right angle triangle. Now we can calculate this equal to hypotenuse square minus perpendicular square, and 1 can be written, 1 square can be written as 1. Then base of this triangle will be under root 1 minus x square. And now we can write tan theta equal to perpendicular upon base x upon under root 1 minus x square. Now we can put it here instead of tan theta. Then it will be x upon under root 1 minus x square plus c. This is the solution of your given question. Now, second part of this question. Second part of this question is also similar as first part, and you can easily solve it without any problem if you try. But I am going to tell you, don't worry. Second part of 11. I equal to integration of x plus 1 upon x square plus 1. This is in under root position dx. Now it can be written as x upon under root x square plus 1 dx. You know it very well. Plus 1 upon under root 1 plus x square plus 1 dx. This is the standard form. You can apply the formula, and now here we can put, let x square plus 1 equal to t, 2x dx equal to dt, x dx equal to 1 by 2 dt. That is why I equal to 1 by 2 dt upon under root t plus this is equal to log x plus under root x square plus 1. Now we can write it 1 upon 2 t power of t minus 1 plus 1 by 2 minus 1 by 2 plus 1. I write one step for you so that it will become easy for you. You can write it here 1 by 2 power of t minus 1 by 2 dt plus log x plus x square plus 1 plus c. Now we can apply the formula of integration of x power n, which is standard formula. Now it will become 1 by 2 power of t minus 1 by 2 plus 1 upon minus 1 by 2 plus 1 plus log x plus under root x square plus 1 plus c. It is equal to 1 by 2 into minus 2 upon 1, 2 upon 1 t power 1 by 2, that can be written as under root t, 2 cancelled by 2 plus log x plus under root x square plus 1 plus c. Now you can put the value of t, and the value of t equal to x square plus 1. Then it will become under root x square plus 1 plus log x plus under root x square plus 1 plus c. This is the solution of your question. Yes, bete, today these questions are sufficient. Tomorrow we will take further questions of this exercise. Thank you very much.